We are introducing PICOntrol, which enables the user to freely control various physical devices using a handheld projector and inexpensive sensor units. To control a device, the user aims the handheld projector at it, casts the projected interface component over the sensor unit, and issues a command by pressing a push button. Controlling another device is as easy as pointing at it. We use an off-the-shelf handheld projector. 3 push buttons are added to enable basic input on the projector. The first button activates input on the target device, while the other 2 buttons allow switching between projected interfaces. The sensor unit comprises a photosensor, an indication LED, and an optical diffuser. In our prototype setup, it is connected to an Arduino microcontroller, while in the future it may be integrated into various electronic devices. The image contains both the visible interface for the user and the embedded control information for the sensor unit. By changing pixel brightness at a high frequency, different areas can transmit different temporal codes within the same interface. These codes can either send a control command, allowing the user to activate various functions in the interface, or encode a position, which allows the sensor unit to locate itself within the image. Using this transmitted location, PICOntrol enables adjusting continuous parameters. It also allows for crossing interfaces. The interaction is not limited to a single device, but can continue across device boundaries. Flicking gestures can be performed by moving the projector. Various elements can be combined into a single user interface. For devices too small to have practical input mechanisms, PICOntrol can provide a rich visible control interface, such as for controlling an MP3 player. Or inputting text on a small device. Alternative to moving the projection, we may also move the target device to allow for interactions with the cast shadows. Combining 2 sensors into a single unit broadens the interaction space, as 2 locations are detected at the same time. Now, the rotation angle between the projector and the sensor unit is known. As well as an approximate distance. PICOntrol can directly map the projector's rotation to continuous input, for example, to set a time on a clock. Combining rotation and linear motions, we can directly control a robot car through projection. Rotating the projector directly rotates the car. Swiping the projection across makes it move into the indicated direction. The same principle allows the projection to act as barrier to stop the car. Applying a different interaction metaphor, The projection acts as a leash to guide the car. Once within the projected area, the robot will continue moving towards it. A third variation of sensor units is able to detect RGB colors by using 3 sensors with different color filters. This allows for directly interacting with the mood lamp by positioning the desired color over the target sensor. In summary, PICOntrol provides a direct, visible, and rich interface for controlling various physical devices.